Hey guys, I think that we should start working on these leetCode problems systematically, which means we should do similar questions together and find the patterns that we can learn from it. So today I'm looking at the recursion. This is one of the problems in the Explore tab of leetCode. If you tap it, click the code, you will like explore. The first one is a recursion 1, so I'm doing recursion 1. So the principle of recursion, it's very simple. So I'm currently in progress of recurrence relation, and this is the second problem of recursion relation. The first one is Pascal's triangle. I've already finished it. So the Pascal triangle is so we should print out the items of each row in this format. So it's very I did it with the recursion. So the recursion just get a parameter of rows, how many rows there are, and do it recursively. For the first two, if 0 and 1, we have the hard-coded results. For the other cases, we get the previous result and calculate the next one and push it to the final result array, and we return. So that's the recursion solution for the Pascal's triangle. And now we have Pascal's triangle 2. So let's see what the problem is. The problem is we give a non-negative index k. We turn the kth index row of the Pascal's triangle. Note that the row index starts from 0. Okay. So we are different from the previous questions. We don't need the final total all the rows. We just need to do final rows, right? So for given the input is 3, 0, 1, 2, 3, we have 1, 3, 3, 1. Actually, this is very simple because we could do it recursively. So get row index. If row index equals 0, we return 1. For the other cases, we should get prev row equals get row index -1. And now we can calculate the final row, right? So actually it should be what it is actually. Anyway, we just create a new array because the result equals 1, because the start and the ending item must be 1, and we need to calculate it, the items between them. And for let's I equals 1, I smaller than row index, because the row index starts from 0 and the items, the length of each row actually should be the row index +1. So this should be +1 and -1, and this is the item length, so -1 again. And am I right? Wait a minute. So if we get the index of this one, so this should be 2 and 4, 3, 4, 2. So it should so it should be not -1, I plus result push pre-row I-1 plus pre-row, not pre but pre-row I, right? And then we result push I plus push 1, and finally return result. It should be done, right? We run the code. The answer should be right, so submit, accepted. See the more details. It's not fast. Okay. What's the problem here? So when we're getting the row of like the fourth row, we first get a second row and then get this first row, get the row here. Actually, the time complexity doesn't change very much if we do something like this, right? Yeah, I think there's not so much improvement here. Maybe because we just use recursion. Of course, every recursion could be rewritten in iteration. Well, I think this is good enough. And could you optimize your algorithms use on OK extra space? Actually, we are using a space here. Actually, use K square space because we have a stack. We have a stack. Like when we get to the row of the third, like this row, we first stack it and call the row of getting this row. So we stack it, and but the stack doesn't actually accumulate. It should be a garbage collected. So in JavaScript, yeah, when this is done, so the problem is we have K, OK, big OK, the time, the space, extra space, plus K, so O2K, so actually this is OK extra space. Let's take a look at what the fast solutions are. Like this one is super fast. I mean, actually we can do direct calculation here for each element. Maybe. Actually, this can be calculated. There should be a way, but yeah, let's take a look at how it is done. Get row, reduce. Yeah, use the native reduce, maybe cool. Yeah, I don't think theoretically it changes much, but well, let's try it. Okay, so actually if we get the row of the third one, The reduce is very simple. We just reduce them, or reduce by sum them up. So let's reduce. Okay, prev row reduce. The first we'll just say reduce. Actually, the first parameter of reducer is that yeah, we just use A. Okay, B is item. This is not cool. Result. Okay, we can use this one. Return result, but we need to result push. No, we actually the prev. We use prev. Okay, prev is 0, so we actually use result push prev plus item and return prev return item. This is okay. So for this 1 plus 0. Reduce. Wait a minute. So it should be reduce the sum of the first one and the second one. Okay. Because the we can just return the item, but we only push if the second one. So if prev is not equal to 0, we push. And then finally we push 1. I don't think this changes much. Yeah. Anyway, this problem is done. We will then take a look at the next one. Reverse linked list. Reverse a singly linked list. Input. Okay, well, I'll record this in another video. See you next time.